So let's try a few examples. So we'll create a dictionary. We're using the squiggly brackets. On some keyboards, that's the shift on the square bracket key, maybe somewhere else on your keyboard. And we're going to use the squiggly bracket, list our elements in the dictionary. So each element of the dictionary is a key value pair. And the entries in the dictionary will be the elements and their atomic numbers. So we have the string hydrogen with its atomic number 1. And we have carbon with number 6. So we've created the dictionary. And what we see when we print it out is the elements of the dictionary. Now, one thing you might notice is they're not in the same order that we put them there. If you think about what we did with hash tables, this isn't so surprising. When we put elements in hash tables, well, where they end up in the hash table depends on the key and the hash function. It's not necessarily in the order that we put them in. And with the dictionary, because it's implemented like a hash table, we see the same thing. Unlike a list where the elements are ordered, with the dictionary, there's no order to the elements. So when we print it out, they might appear in a different order from the order that we put them in. We can use the indexing to look up one of the elements. So now when we look up the value associated with hydrogen, we get 1. And if we look up the value associated with carbon, we get 6. What do you think is going to happen if we look up a value that's not in the dictionary? So now we're looking up the value associated with lithium. And what we get is an error. It's called a key error. It says that element is not in the dictionary. This is different from how we define lookup for our hash table, right? We defined our lookup to return none when the element was not there. The way the built-in dictionary type works is it gives us an error when it's not there. If we don't want to get errors like that, we can use the in to see if an element's in the dictionary. So the in behaves similarly to in did for lists. We can say lithium in elements. That will evaluate to true if the key is in the dictionary, false otherwise. So now it evaluates to false. So I said that dictionaries were mutable, so we can add new elements. And the way to add an element is just to use an assignment. So we'll add lithium, giving it value 3. Note that it was an error when we used an element like this as a lookup when it's on the left side of an assignment. Well, that's an update. So that corresponds to the hash table update where lithium is the key and 3 is the value. We can add another element. Let's add another element. We'll add nitrogen. And now when we look up nitrogen, we get the value that we assigned to nitrogen, which is 8. Turns out that 8 is not actually the correct value. The atomic number for nitrogen should be 7. So we can modify that value using another assignment. That's, again, the same as our hash table update. It won't create a new key value because the key nitrogen is already there, but it will update the value. So now the value associated with nitrogen will be 7. So we can see the first print, the value is 8. The second print, the value is now 7.